Packaging houses serves as a collection center for fruits and vegetables prior to distributions and marketing. The houses can be simple packaging sheds with a limited equipment and minimal operations, or a large complex that is well equipped and with the facilities for specialized operations. The type of operations carried out vary with the different commodities and market requirements. Packaging to reduce food losses. Fresh fruits and vegetables are living products. These products need oxygen to live. This is because their metabolism remains active even after harvesting. The two most important processes in these are respiration and transpiration. In the case of respirations or breathing, the plant absorbs oxygen and gives off carbon dioxide, water, and in the case of transpiration, which also takes place during the growth process as well as after harvesting, they also absorb oxygen. The consequences are ripping, fermentation, discolorations, and then finally spoilage due to decay of cellular structure. The growth of mold and other undesirable microorganisms. Many fruits and vegetables basically respire more quickly and can be therefore spoiled more rapidly. Others respire more slowly and can therefore be kept longer by themselves. The frequency of respirations is however different and also depends on the season, environmental temperature, region, or time of harvesting. Food waste 1.3 billion ton per year. In case of fruits and vegetables, it is as much as 50% of the cultivated crops. Losses in food supply chains of fresh fruits and vegetables occur during harvesting, post-harvest handling and storage, processing stages, distribution and consumption. Reduction in the post-harvest losses plays an important role in the sustainable feeding the world population in the future. Minimization of fresh fruits and vegetable losses is a critical issue. Improvements in post-harvest technologies such as packaging systems are vital to minimize post-harvest losses and to improve quality characteristics of fresh produce. Packaging solution for minimizing food waste during post-harvest. Possible reasons for fresh fruits and vegetable losses and potential packaging solutions. Bruising due to compressions of overfilled packages that can be reduced using a solution. The use of shallow and smooth surface containers decrease in the weight of produce in containers. Vibration injury during transportation. Optimizing transport packaging for shipping. The use of restrainers, individual wrapping and cushions. Impact injury. The use of rigid containers with cushions of each product.
Puncturing injury. The use of rigid containers with proper grips. The use of smooth containers and handling equipments. Water losses or whittling. The use of advanced packaging techniques such as MAP and active packaging. Microbiological growth. Combined treatment of MAP and irradiation. Inadequate ventilation. The use of packaging material allowed respiration. Consumer behavior. Excessive purchase. Introducing smaller consumer packaging in the markets. Characteristics of a good package for fruits and vegetables. It should occupy less space when empty. It will facilitate cost-effective transportation of empty boxes and convenient in storage while not in use. Collapsible plastic crackers and corrugated fiber boxes. It should be easy to assemble, fill and close either by hand or by use of a simple machine. Semi-skilled laborers can also fill and close comfortably. It must provide adequate ventilation and overall protection for content during transportation, storage and marketing. Its capacity and size should be designed according to the market demands. it should have a proper dimension and design which are suitable for transport systems to prevent any vibration damage. It should be environment friendly, reusable and biologically inactive. It should have sufficient strength in order to protect the contents against physical injury during entire distribution chain. It should not damage while doing special treatments like pre-cooling, fumigation, etc. It should be resist to the moisture and free from any sort of smell. It should have attractive shape, size, color, should have consumer appeal. It should provide information desired by consumers. It must be cost effective in relation to the market value of the commodity and the cost of packaging material. Type of packaging material. Choosing the packaging material depends on factors such as nature of the fresh produce, biodegradability, recyclability, shelf life and sales appeal. Packaging system for a fresh produce and vegetable. Flow pack packaging system. Fully automatic flow pack systems can work with different packaging material and have a horizontal or vertical operations options at different speeds and capacities. In flow pack systems, the result is a flexible package. Example of horizontal flow package machinery. Examples of packaged products. Thermoforming packaging of fruits and vegetables. Thermoforming is a plastic molding process in which the thermoformable material, a sheet of polystyrene (HIPS), polypropylene or similar plastic sheets or film is heated and the sheet is then pulled down over a solid mold to obtain a desirable shape. Examples of packaged products. Tray sealing packaging of fruits and vegetables. In a tray sealing system, after the product is filled into the trays, the rigid trays are transported in a closed chamber in which air extractions and gas flushing is done. They are generally used in MAP and vacuum packaging of fresh fruits and vegetables. Stretched film wrapping of fruits and vegetables. Stretched films are stretchable plastic films that can be wrapped around the fruits and vegetables which are held in a preformed or foam trays. A stretchable film must stretch, retain its elasticity and cling to the package and itself when wrapped in layers. It forms a compact, durable, flexible, moisture-proof covering. Advanced packaging system. Appropriate packaging materials and advanced packaging systems need to be developed to reduce post-harvest losses and increase the shelf life of fresh fruits and vegetables. Actually, there are various advanced packaging systems available for the fresh fruits and vegetable packaging. Modified atmospheric packaging, that is MAP, active packaging, smart intelligent packaging, biodegradable packaging. What is modified atmosphere packaging? MAP is a packaging concept based on a modified normal composition of air surrounding the product in a package. Shelf life of fresh produce, fresh fruits and vegetable is prolonged with the help of MAP by controlling the level of oxygen and carbon dioxide within the packaged products. It slows the spoilage of fresh fruits and vegetables. Mechanism of MAP of fresh produce. MAP should be carefully designed in order to prolong the shelf life of fresh fruits and vegetables, otherwise it can be ineffective or even causes adhere effect on the shelf life. For instance, it's advisable to keep MAP applied products at a low temperature, usually from -1 to 7 degrees Celsius. Factors affected designing of MAP. Temperature, gas composition, product characteristics, that is respiration rate and masses, permeability of packaging material. The benefit of MAP can be summarized as follows: preserving nutritional quality, phytochemical compounds, attractive colors and sensory characteristics of packaged products, improving moisture retention, minimize water loss, protection from chilling injury, decay and microbiological spoilage, delaying enzymatic browning reactions, providing centralized packaging and portion control, reducing respiration rate and ethyl production, isolating the product from the external environment and thus reducing exposure to the pathogens and contaminants, little or no need of chemical preservatives. In the MAP techniques, the modification of ambient temperature atmosphere is performed in two ways, passive and active. In passive MAP, respiration rate of a fresh produce and permeability of the packaging materials are most important parameters. The desired atmospheres develop naturally as a result of respiration of fresh produce and the diffusion of gases through the film. In case of active MAP, the gases in the package are replaced with a desired mixture of gases. Suitable gas composition inside the package depends on the type of fruits and vegetable. However, gas composition ranges from 2 to 5% O2 and 3 to 8% carbon dioxide are generally recommended for MAP treatment of fruits and vegetables. Plastic bags used in the MAP of fresh fruits and vegetables are generally made from byproducts in the mineral oil refining industries. Flexible plastic packaging material comprise nearly 90% of the material used in MAP. These materials provide suitable permeability to the gases and water vapor and the strength needed for MAP. The shelf life of packaged products can be extended by 50 to 200% by using well-designed MAP. Active packaging, it refers to the incorporations of certain additives into the packaging film or within packaging containers with the aim of maintaining and extending product shelf life. Extra features are added to the packaging material used as a barrier in protecting the product from external factors. It's a very efficient technique for fresh fruits and vegetable packaging due to providing better packaging characteristics. Smart packaging. Smart packaging, also known as intelligent packaging, can be defined as a packaging system containing indicators used for monitoring movement, conditions and quality of packaged fresh produce along the supply chain. It provides better control of quality and safety of fresh produce. Moreover, this packaging concept communicative functions so as to assist consumers in making purchasing decisions. Biodegradable packaging. The use of natural biodegradable products as an alternative to synthetic chemical has shown remarkable improvement in terms of maintaining quality of fresh fruits and vegetables and extending their shelf life. Biodegradable packaging refers to the packaging material that can be decomposed into natural element by the action of living organisms after disposal. Biodegradable polymers that have found commonly applications in fruits and vegetable packagings are starch, cellulose, protein, chitosan, PACL, PLA, and PHP. The combination of biodegradable packaging materials and advanced packaging systems both extended the shelf life fruits of vegetables and fruits, also reduce potential packaging waste. Therefore, this combination can be considered an ideal packaging system for fresh fruits and vegetables.